Did you know that right now, 80 to 90% of the massive AI compute cycles running all around us rely entirely on invisible hardware approximations? We are literally talking about pure guesswork rather than exact, traceable math. It's a genuinely astonishing figure, and honestly, it fundamentally changes how we should be viewing our entire digital world.
Welcome to this explainer. Today, we're putting on our digital detective hats to uncover a pretty catastrophic architectural failure buried deep inside our computer hardware. But don't worry, we're also going to reveal its profound, quantum-level solution.
Okay, here's our roadmap for today. We'll kick things off with number 1, the FPU gambler crisis. Then 2, the illusion of quantum probability. 3, the finite observer theory. 4, enter the ALU surveyor. 5, the HSDB patent solution. And we'll wrap up with 6, the SYN kernel bouncer. Let's dive right in.
Section 1. The FPU gambler crisis. Fast, lossy, and unauditable. So to truly understand the rot currently living inside our digital infrastructure, we have to descend all the way down to the microscopic metal. We need to take a hard look at a component called the floating point unit, or simply the FPU. See, the FPU is designed to process heavy math incredibly fast. But to pull that off, it uses secret, proprietary silicon seed tables to frantically approximate continuous math. It is, fundamentally, a probabilistic guesser. It's exactly like a giant blender. Think about it. You know exactly what pristine fruit you put into the pitcher. But once it's blended, you can absolutely never unblend that strawberry smoothie to get your exact fruit back. It permanently destroys your data's provenance.
And because of this microscopic rounding, we experience what researchers call the wood chipper effect. When AI ingests exact source data, say a copyrighted book or a critical financial record, the hardware approximates the math using those trade secret silicon tables. The result? The exact digital receipts of your data's origin are totally shredded. It creates this irreversible informationally depth, meaning you can never trace that data back to its true source.
Section 2, illusion of quantum probability, the physics parallel. Now, you know what's absolutely fascinating? How this chaotic hardware guessing perfectly mirrors a massive ongoing debate in the realm of quantum physics.
Take a look at this fundamental clash of paradigms. Nobel laureate Gerard 't Hooft actually suggests that standard quantum mechanics isn't the fundamental reality we thought it was. Instead, it's really just an emergent statistical tool for macroscopic slow variables. It essentially masks an underlying, strictly deterministic microscopic reality governed by exact discrete rules. Just like the FPU approximates data because it can't handle the full complexity, standard quantum mechanics is basically a blurry approximation of a perfectly exact universe.
Moving to Section 3, the finite observer theory, a verbless geometry. This physics parallel directly leads us into a paradigm-shifting framework called the finite observer theory. This theory completely strips away active verbs like time, evolution, and interaction from the universe's foundational structure, replacing them entirely with a static, relational geometry.
So why does our universe look continuous and probabilistic if it's actually fundamentally discrete? Well, it's because a physical observer, like you or me, has a finite capacity to process information. We simply don't have the memory to process the infinite complexity of the entire universe. Because of that, we are mathematically forced to execute what physics calls a dimensional partial trace. In everyday terms, our brains project a lossy, blurry 4D reality out of a perfectly exact, discrete network. That probabilistic fuzziness we see in quantum mechanics and the approximations in our FPU hardware, they're literally just artifacts of our finite capacity to observe.
Section 4. Enter the ALU surveyor, reclaiming hardware truth. Okay, so if reality's foundation is fundamentally discrete and deterministic, we desperately need computer hardware that operates with that exact same fidelity. We cannot keep relying on the guessing game of the FPU. When we finally pit the FPU gambler against the arithmetic logic unit, the ALU surveyor, the difference is night and day. While the FPU frantically throws darts in the dark using those secret seed tables, the surveyor acts like a professional out in the field with a precision laser. It deals strictly in undeniable hardware truth, using exact discrete logic gates with absolutely zero hidden tables. By relying strictly on the exact clocked voltage metronome of the ALU, where high voltage is unequivocally a 1 and low voltage is a 0, we guarantee that 1 plus 1 equals exactly 2, universally, on every single machine on Earth.
By enforcing this, we actually restore Noether's theorem back into computing. That's the physics principle that true reality is completely reversible. If you can go forward, you can perfectly retrace your steps backward, handing us an unbreakable chain of title.
This perfectly illustrates the switchback effect in practice. It shows how incredibly complex algorithmic pathways can track deterministic perturbations without permanently losing a single drop of information. Because the system is rigidly exact, operators that don't actively affect the mathematical pathway just cleanly cancel out. It acts as a true universal witness, preserving perfect data provenance instead of shredding it.
All right, Section 5, the HSDB patent solution, nouns and verbs united. Here's the massive challenge we face. How do we actually bridge our messy, probabilistic human intent all the way down to this rigidly exact ALU hardware without breaking the whole system? We need a translator.
Enter U.S. patent number 12,664,142, the Hierarchical Script Database, or HSDB for short. This isn't just a piece of software, it's a literal bridge to deterministic quantum mechanics. It forces fuzzy human intent into strict constraints that the ALU can actually execute safely. By using a JSON-like nested tree structure, the HSDB takes passive data, our nouns, and active logic, our verbs, and unifies them. It co-locates both into single, unified execution nodes. This is absolutely revolutionary. By fusing data and function into a single node, we create the physical realization of the finite observer theory right in our architecture. We permanently shift execution away from probabilistic guesswork and create a localized, event-driven engine that eliminates the need for chaotic external event loops that usually cause non-deterministic drift.
Which brings us to our final part, Section 6, the SYN kernel bouncer, enforcing deterministic law. Of course, when your database acts as a self-reproducing automaton, spawning new nodes dynamically, you need an uncompromising gatekeeper to maintain that perfect order.
That gatekeeper is the mathematical SYN kernel function. I want you to picture this as a super strict bouncer standing at the door of a club. Step 1, the thesis. It checks if a highly specific slot in the JSON tree is actually empty. Step 2, the synthesis. If it's open, come on in. The new data is seamlessly synthesized. But step 3, the antithesis, is the kicker. If data already exists in that spot, the bouncer violently rejects the input. No accidental overwrites, literally zero exceptions.
This strict sequential architecture provides what we like to call deterministic elegance. It evaluates logic before a single byte is ever written to the disk. It completely eliminates the chaotic scope issues and accidental overwrites that plague traditional programming. Every single decision traces back to a highly auditable, mathematically absolute line of code.
Let's bring this all together. By replacing the FPU gambler with the ALU surveyor and utilizing the patented HSDB architecture, alongside the strict SYN kernel, we physically realize the finite observer theory. We can permanently bypass the probabilistic guesswork of mainstream quantum physics and anchor our digital reality in absolute, exact truth. I want to leave you with this final provocative thought to chew on today. As we increasingly entrust our legal, financial, and societal futures to machines, which reality will you accept? Will you settle for the gambler's guess, or will you demand the surveyor's exact truth? The choice of how we build our digital infrastructure is entirely up to us. Thank you so much for joining me on this explainer, and keep questioning the systems around you.